Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. All right. Well, welcome everyone. Today we have with us Vivek. Did I say that right? From
Yep.
Toronto. And what's your last name?
Sekhar.
Sekhar. And so you and I started working together recently around some Wasm stuff. And Bruce and I it keeps coming up. Like Wasm is this exciting thing with lots of stuff happening around it. We're like, we got to have somebody on to talk about Wasm. So here we have Vivek, yay, to talk to us and help us learn about Wasm.
And before we get started, I want to plug the Winter Tech Forum, which is coming up in a couple of weeks. You can still come.
Yes, in Crested Butte, Colorado.
Crested Butte, Colorado, and we're getting more snow as we speak. So, I mean, you don't have to be a snow person, but if you are, it's nice.
I'm really excited. I'll be here, of course.
Yes. Yeah.
But I think we have a decent number of people coming.
Yeah,
and so
enough to make conversations, which is the whole point.
So, I'm sure we will spend some time exploring Wasm.
Yeah, maybe that'll be the Hackathon Day project or suggestion.
Unless I get sucked into Nix. So I've been on this Nix thing.
Nix kick.
Uh-huh. And
Nix
there's
for kids.
My to-do list with Nix, it initially started shrinking, and now I'm at the point with Nix where my to-do list is growing. And so could maybe do some Nix stuff. Or that Easy Racer thing I've been working on?
Yes.
So Jack, we know Jack. I wonder if he's going to be here this year.
Didn't seem like it.
Yeah, shoot. He contributed the Go version and is working on a Swift version. And then someone else just contributed a Scala one with something that uses Loom underneath the covers with Scala. And it's really nice. Like you got to see this. It's called Ox is the name of the framework for structured concurrency in Scala with Loom.
Huh.
Anyways, we definitely could spend some time on Easy Racer.
Oh, right. Okay.
Winter Tech Forum.
Yeah.
Where I was going with all that.
There's all kinds of possibilities. Anyway, we were going to talk about Wasm.
Wasm. Okay, Vivek, tell us about yourself.
Sure. Yeah, I'm a product manager working with the Chrome team on our web platform side of things. So we have one group that works on the user-facing side for the Chrome browser, and another group that works with the various standard bodies and partners across the web ecosystem. And I've been working for the last couple of years on Wasm or WebAssembly, and it's this incredibly exciting new technology that started years and years and years ago, but is now really kind of becoming super relevant and exciting for a lot of different reasons. And we're working with folks working with JetBrains on a Kotlin compiler to WebAssembly, as well as a whole bunch of other potential technologies and use cases. It's a super exciting time to be working on WebAssembly. It's really great to share it with you guys.
And James, you just tried the Kotlin for Wasm.
Yeah, we just got to dive into it last week. And
you got something working.
The hardest challenge was Nix. Back to full circle back to Nix. We had some challenges getting some Nix stuff working in Nix and build and went to Ubuntu.
Affect anyone else.
Wasn't totally unrelated to Wasm and Kotlin Wasm, and so we got some basic stuff working last week, and it's cool. Like for years I've been hearing about all the excitement around Wasm, and the thing that's always kind of kept me from it is that until the Wasm GC stuff, which we'll get into, I've never actually done C or C++. And so that was just kind of not a way for me into Wasm. I've done a tiny bit of Rust, and that I could have done the Rust Wasm thing. And I think that's interesting. There's a lot of cool stuff happening there. But for me, I like the modern's not quite the right word, the higher level languages. And so now that we're getting some of these higher level languages being able to target Wasm,
you could almost say the happier path.
The happier path.
Right.
Yeah.
Yeah. Sure. High level languages allow you to do more with less work.
Yeah. So I think maybe where we start this is to talk about what has been done for ages, over a decade, maybe two, with the web, is that if you had a language that you wanted to use and you wanted that language to target the web, which was, and your language is not JavaScript, you had to transpile your language into JavaScript. And there are just probably endless issues with this approach.
Oh yeah, I used CoffeeScript, and it was actually, I mean, compared to JavaScript, it was nice, but
better than JavaScript.
But I guess JavaScript has gotten a lot of better things in it since
well,
then.
Now a lot of those people that want a better JavaScript are doing TypeScript.
Yeah, I think TypeScript kind of taken over.
But I think for a long time, a lot of people have wanted something that was able to run in the browser that is not JavaScript.
I certainly have.
And so thus Wasm, right? Is Vivek, are we getting that right?
Yeah. No, there's been a whole bunch of different inroads in the direction of Wasm, I like to think conceptually, and one of them is exactly that. It's like, it's hard to say you have fully explored what it means to be a platform if there's only one language that runs on it. And so we've kind of intuited that we want to kind of open up the web to lots of different languages and give them a fair shot at full kind of device performance. And that wasn't really possible in that world that you're describing, where everything has to be routed through JavaScript and inherit all of its quirks. And some of those quirks are really amazing if you're writing JavaScript code or TypeScript code. It's very dynamic, very easy to write. But if you're writing C++ code, you definitely don't want to be, running that through JavaScript, because there's just so many different properties that are going to get in the way. So, yeah, I think
as an example, one of these that I think I've heard about is the way that numbers are represented in JavaScript. That if you are transpiling to JavaScript, you assume this weird thing about JavaScript, which is like every number is internally a float or something like that. Is that?
Well, it's internally unspecified, right? Like, so an implementation.
Oh, that's right.
Even better.
Do what it needs to do. Exactly.
It's just anything.
Right.
Yeah.
But that's the nature of these sort of like dynamic environments, right? Like it's an idealized programming environment that's really great to use, but it requires some machinery to actually make that run on a physical machine. And that machinery is expensive and not always well specified, and has runtime costs. So yeah, numbers are a great example. There's a thing called boxing your types. So basically, you put everything into a container so that you don't have to worry about how big it is inside. There's a bunch of other things that interpreters do. And if you need it, it's great. And if you don't need it, then it's kind of overhead.
And a related limitation, I think, with this is that in JavaScript, you can only go up to like an int32 in terms of integer representations, right? And so if you need something larger than int32, then you just are like, well, like it gets hard, I think.
We just use 2.
That's right. Combine 2 ints together, and there you go. Yeah. Anyways, this is, and I'm maybe not 100% getting this limitation correctly, but I think meta point is that when you transpile to JavaScript, when that is what defines your limitations, you're always going to be bumping against something that is not quite the way that you want it to be. And so many years ago, this idea to have an assembly language underneath JavaScript came about, and that was WebAssembly. Is that?
Wait a minute. Let me try this, because my understanding was that JavaScript runs on a virtual machine, and so it has bytecodes. Is that right? Does it have bytecodes?
It has, yes, there are certain intermediate representations between the JavaScript you would write by hand and the code that's ultimately executed. But there are various bytecodes actually going all the way down to machine instructions in a just-in-time compiler. So yeah, it's a whole spectrum inside the interpreter magic.
So my understanding of Wasm is that it's some Turing complete subset of those bytecodes that you're targeting when you're compiling from another language. Is that right?
It's not quite a subset. It's actually kind of a new language on its own. And so, but it's meant to be very close to the low-level machine languages of a lot of different machines. So the idea with WebAssembly, and this goes, even before there was WebAssembly, we at Google had a technology called Native Client, where you could compile a C++ app, similar to what you would build for a desktop app, like Google Maps back in the day, Google Earth back in the day, and then you could ship that code as an exe that would then run, inside a sandbox in the browser natively on your device, but still sort of protected in the web runtime environment. And so what we wanted to do was take that technology and not make it sort of specific to one platform or one provider. We wanted to open it up. We also didn't want to necessarily fix the technology on any one machine architecture. So we didn't want it to just be for Intel processors or ARM processors. We wanted it to kind of be general. So you can think of WebAssembly as the machine language for a logical processor, a processor that doesn't physically exist anywhere, but has a well-defined set of behaviors the way a physical processor would. And WebAssembly is easily translatable into the physical instructions for a lot of processors that exist today, including ARM devices on mobile, as well as Intel devices on desktop.
So it sounds a lot like what they did with the Java Virtual Machine, but you're saying that they actually created a bunch of. Did they create a whole new set of opcodes, or were there some that were already okay and so they could use those and add? And also, how did they shoehorn this into this JavaScript world?
Well, yeah, that second question is a very big, open, ongoing design question in the community. But in terms of designing the machine, I think they were able to sort of learn from the kind of maturation of machine instructions over the many years. Like x86 has been around for a very long time. ARM has been around for a very long time. All these machine language instructions or instruction sets have kind of coalesced around a common set of register machines and stack machines and common concepts, virtual memory, that sort of thing, that have kind of built up over the many years. So they had a really great starting point just in the computer science ecosystem and the software development ecosystem. And so it's not quite sort of like inventing a whole new machine that's never existed before. It's actually just polishing some of the rough edges of individual architectures and creating something new.
But so real quick, when WebAssembly was created, part of that creation was to at least standardize the bytecode opcodes that were going to be supported by this probably at the point theoretical Wasm machine.
Yeah, exactly. So the Wasm standard essentially is a standard for this machine and what it will do when it encounters each one of these bytecodes and how it kind of manipulates memory, and all the kind of performance characteristics around it. And for the two platforms that are most popular right now, x86 and ARM, as well as we hope future platforms, it should be very easy to realize that those performance requirements and that specification without the kind of heavyweight interpreter that you have today with JavaScript. And so at least on platforms like Android and Chrome and V8, we actually can lower those instructions directly to machine code instructions. It's a little bit trickier on iOS because they don't allow kind of code pages to be JITted. But that's the idea of kind of like it basically is as close as possible to a machine instruction without being tied to a particular machine vendor.
Huh. What's amazing is that this came, I guess in a lot of ways, the web is creating this common denominator across platforms. And so it seems in some ways weird that this common assembly language, common bytecode would come kind of through the browsers and through the web, but then it also kind of makes sense because of the web has always kind of done that sort of thing. So yeah, fascinating.
Yeah, and so, what we're seeing actually, WebAssembly being pulled in the other direction. So we created this, like you said, for the web to run on all different platforms. But now WebAssembly is starting to show up on cloud computing platforms and edge computing platforms because of exactly that. It's this common sort of isolated runtime. It's kind of doing for containers, it's doing at the instruction set what containers did for the kind of operating system environment. You can create a packaged binary that truly does
that is portable,
and that's super exciting.
Yeah, so back to Bruce's question, which was about
how do you get this? I mean, you've got this huge JavaScript world, and so does JavaScript itself get rewritten to use WebAssembly, or
yeah, what's this?
How does this work?
So in the what we call the WebAssembly MVP, the minimal viable product that sort of we put out as an initial standard, basically it's JavaScript. You instantiate a WebAssembly runtime from your JavaScript environment. You load a WebAssembly binary into it, and then you can start running it. And there's some very simple kind of interop where you can kind of basically just exchange numbers, right? And so you can construct higher level data structures from these kind of composites of numbers. That's just sort of a very basic kind of, we needed something, and so we put this in place. But it's by no means the end state. When we get into what we're now looking at, what we call Wasm GC, which is an integrated heap between JavaScript and WebAssembly. What that basically means is if you're writing code in Kotlin or in a JVM language, then when you allocate memory in that language, you're actually allocating memory from a common pool with the JavaScript code that's running next to you. And so that, if you kind of squint, that helps you interoperate, because now you can pass objects between Kotlin code and JavaScript code and back again. And the garbage collector just kind of knows where all the objects are and can collect cycles and things like that. So that's a big sort of thing that we're launching this year that will enable languages like Kotlin as well as Dart to run in this WebAssembly environment in a way that doesn't require shipping a whole lot of their own infrastructure. That doesn't solve the problem of how you interoperate with JavaScript, but it's the beginning of a solution, because JavaScript is this incredibly dynamic language. You need to have at least some dynamism to your object allocation just to even start that conversation.
Are you specifying how a data structure should be laid out? I mean, when you talk about passing objects between one language and another, do you, how do the languages know what the objects look like?
So right now, that's very much left to the implementation. So if you are writing, JavaScript code that connects to your Kotlin code, you kind of have to understand what exactly it is you're passing back and forth. Our hope is that, libraries will be written to help facilitate that. But at the standards level, we're still a couple of layers below solving that problem. We're just kind of making it possible to pass objects without messing up memory allocation. And then we'll kind of explore further things above that. One example of a higher order structure that's just kind of one click higher than garbage collection is the string ref proposal, which is a very new proposal, but it's an attempt to say, well, look, everybody's going to need strings. These strings are often dynamically allocated. They're often passed back and forth across this boundary. So maybe there's a kind of common, lowest common denominator for strings that we can agree on. And then make that work in a way that's sensible across JavaScript. Still a very challenging space. A lot of discussions happening there, but it's exactly what you're describing in terms of
like an example,
progressing.
like some languages will use UTF-8, some will use UTF-16, some will use some other representation, and being able to have a string reference across both sides, like not get screwed up on this is a place.
And the big one is JavaScript uses UTF-16 and very few other languages do. And so we have this interesting problem where the strings on the web are a special case. Even internally inside Chrome, we have different representations for strings, as many large software products do. And so, it's definitely an area for further research.
Yeah. So maybe I missed this, but it sounds like there's a standards committee, and it sounds like you're on it. Is this?
So we have engineers who represent our little neck of the woods, Chrome and V8, on the standards committee. We also have representatives from the other major browser vendors. So it's a big kind of open community process. There's also a very significant participation from the academic community, because, like I said, we're designing this logical machine, and this is a very kind of complex and abstract undertaking. What is that type system? How does it interoperate with other type systems? So we have so many people to thank for getting us even this far, and we're going to need everybody to go further.
Yeah. That's what I have seen when I've come across Wasm stuff. It's like, oh my gosh, these people are involved, and these people are involved, and these people are involved. It's amazing how many people are working together to push this stuff forward. So that has been cool. So coming back real quick to Bruce's question, where I think he started to ask a little bit about, like, at the runtime side of things, what's the relationship between JavaScript, the interpreter, V8, like all and Wasm? Like, how does all that stuff kind of end up fitting together?
Yeah, so I mean, the JavaScript ecosystem and the kind of major interpreters that are used today, V8 being one of them, they are incredibly mature and incredibly sophisticated. And so running JavaScript code, it's not just like a simple sort of interpreter loop. It's actually a kind of a just-in-time compiler. It's profiling your code as it's running. It's figuring out kind of which code is the hot code and lowering that further, caching different versions of different functions based on the types that are passed into them. It's an incredibly complex system. And so plugging into that, from the static world is very challenging. One of the great opportunities for WebAssembly is you can, when WebAssembly code arrives, from the server, it's already kind of lowered and optimized and a little bit, it's kind of like ready to run at high speed. So we're super excited about being able to build V8 and being able to build browser engines that hit sort of something near their peak performance from the very first, function call or the very first kind of line of code. So that's a real opportunity, I think, for web apps to get really great startup time and to load complex, compute applications that feel native from the very first moment. That's something that's a little bit trickier to do in the JavaScript world today because of the different tiers of optimization and compilers that you usually have to go through.
Yeah, and like the warm-up phase,
Exactly. Yeah.
As you call something more, then it's going to get inlined or whatever
Exactly.
at runtime. But why not just have that peak performance out of the gate?
Yeah,
Nice.
yeah, and the ahead of time compilation model, I think, is something that could really benefit the web. There's still challenges with code size. Ahead of time compilation tends to produce larger binaries than the JavaScript equivalent, so network traffic becomes the bottleneck, and networks are not getting as fast as they're not on the same trajectory as sort of CPUs in terms of performance improvement. So we have to do some work there to try to figure out how to reduce the sizes of these payloads. But the hope is that developers can build their applications and their tool chains will do the work to make those applications ready to run fast right from the get-go. And that's something that I think could bring real value to end users without them even really noticing that there's a change.
Yeah.
So how does it handle, especially on the web where you've got, all kinds of different versions of everything. How does it handle versioning? So, like, in particular, would it be able to cache something if it knew it was the version that it wanted?
Versioning of what? Of a payload?
Like the actual
Of the
Wasm
components.
files. Yeah.
Of the
We
Wasm
should talk about the
components.
component side of it. But
Yeah.
so the Wasm just gets delivered as this like binary file to the browser, right? And then today, the way to then run that Wasm is through JavaScript. You say like, all right, here's your Wasm file with all the bytecode in it. Run this thing. There may be, I guess, at some point in the future, like a ability to just do a script tag pointed to a Wasm file or something. It'll just run it without having a JavaScript wrapper or something. But today, anyways, JavaScript API, give it the Wasm file, it runs it. I think where Bruce was going with this is,
well, there must be some kind of module system,
right? Exactly. So, like, if you need,
and the modules,
how do you split up a application into multiple Wasm files?
Mm-hmm.
This is a great question, and you're asking all the right questions. We don't have full answers to them yet. You're right that the current state is that we have a very well standardized instruction set. We can build these binary files and instantiate them and execute them. How those are stitched together is currently an out of band question, and so a lot of it goes back to that question of interop. There was a series of proposals called interface types, where the ecosystem, the standards bodies and the related interested groups were trying to figure out a way to get different modules written in different languages, even to be able to call into each other and share types. And this turns out to be another one of those big sort of open research problems, because even among static languages, there's slightly different, semantics around what an object is and what it can do and how it's allocated, how big it is, how it moves around. And so there's all these kind of like performance cliffs where you have to convert a string from, like you said, one encoding to another. So yeah, we don't have a good handle on what that looks like. What we're excited about is two main areas, at least in the interim. One is, like you said, shipping whole applications. In some cases, that makes sense because from the developer's point of view, they have a large code base. It's all in a repo. They want to compile it, build it. And they actually kind of want that sort of repeatable experience where once they have that binary, it's kind of frozen in time and they know and conversion it and they know what the user is getting and what the user is experiencing. So for example, if you get a feedback report, you can, get a version number and go back and recreate that binary, trace it, debug it, that sort of thing.
So basically a monorepo.
What's that?
A monorepo, or at least that's what they call it in the Python community.
Yeah, it might be a monorepo, but at least it's potentially a reproducible build. So even if it's coming from multiple repos, you'll be able to actually go back to the same artifact and diagnose it and debug it. The other piece that we're super excited about is the entire library strategy. So there's a lot of libraries, related to text layout, related to internationalization, related to 2D drawing. And these libraries are very mature and very stable. They tend not to change. And even if they do change, they're very minor changes and the API stays the same. And so this is an opportunity where you could have, like Harfbuzz or FreeType or some of these kind of like very stable text and drawing APIs and libraries packaged up in a way that sits on a CDN and can be accessed by lots of different sites without necessarily having to fetch it every single time. And so there's some opportunity even in the static world where we don't have the component model, the dynamic component model figured out, where we can actually recognize that there's certain parts that are kind of stable enough and pull those out of applications.
And there is some proposal for a WASM component model or something, some way to be able to publish a library as WASM, and then have someone else consume that library and use it in their WASM application or something along those lines, right?
Yeah,
Is that
there's a
correct?
couple of different proposals. There's also just simple integration with the JavaScript ecosystem. So you implement WASM as your own kind of implementation detail, and you expose your library as a JavaScript library, and people can npm install and all that stuff.
Yeah.
And so that's just a handy way of using infrastructure that already exists. The overhead for that is not huge. It depends on how frequently you're calling into the library, but the JavaScript wrapper code can be pretty compact. And you benefit from all of the existing sort of ecosystem, the ecosystem of libraries and tools that can operate on that. So that's probably kind of the most active right now, but there may be others in the future.
Yeah, you talked about let's see, containers, and it seems like, well, all JavaScript programs run in a sandbox, right?
Yep.
Okay, so that's maybe a little bit containery, but then there's this WASI thing that sounds like the equivalent. I mean, it sounds like you're talking to the operating system facilities, so it's a little bit like Docker, right?
Yeah, I mean, the whole idea, the whole universe of isolation, application isolation, is super interesting. And yeah, we went from VMs to containers now to WASM runtimes. Node also did this with JavaScript, right? Like you're running inside of a quote unquote web sandbox, and I think it's a real opportunity for WASM for this kind of like shared machine instruction, because you can isolate at the machine instruction layer. So we had a project a couple of years ago called gvisor, where we would basically isolate guest processes and then intercept all the system calls, and we could stub out and kind of secure the process that way. And that created a sort of POSIX compliant sandbox around a process, and it was hugely popular in the ecosystem. I think we've kind of moved on to different hypervisor technologies now. But if you could do that instead of waiting for a syscall, if you can actually do that, simulating each machine instruction and ensuring that it is compliant with some security policy, that's something that the security guys really love. And so I could imagine Wasm playing a really interesting role in the kind of container ecosystem. We've also seen use cases with edge computing because of the fast startup time. So it's really slow to start up a VM. It's faster to start up a container, but it's really fast to just start interpreting WASM. And so there's a potential there for folks to be able to deploy code in response to requests rather than pre-deploying and consuming resources, waiting for users.
Yeah, so a couple things on that. First, I just saw today that Containerd just announced their WASM support. So it is kind of interesting how the whole container world, we basically created a way to, I think, like you said, silo a POSIX, like something that was a POSIX system. And with Docker containers, you get these Docker containers that have a like full Linux system in them, and then you've got this hypervisor outside of it that is controlling what it can actually do. And yeah, I remember, like, seems like every month there's some new security vulnerability where you can escape out of this and actually get to the underlying system, and lots of challenges with it. But it always just seemed like a lot of kind of layers to get to a sandbox that never really worked super well. And so pretty quickly, at least over the last couple months, it seems like a number of these container technologies have enabled support for WASM. And I think that the benefits of it are just obvious. Like you said, like you get all these easy sandboxing benefits with the portability of WASM all combined together, rather than I've been with the Easy Racer project, I had to do Docker multi-platform stuff, and oh my god, like it is not fun. Where I would much rather just ship something actually multi-platform, say Wasm,
And let me
instead.
explain something here. James, I've watched him bang his head against the wall for hours. Like, he will not give up. So when he says, "Oh my God, that was hard," that means something.
Well, and the worst part of it was that GitHub Actions don't support ARM, like physical ARM processors anymore, or yet. And so to create your ARM container, you have to use what's the simulator on Linux to simulate other architectures? I forget what the name is. Anyways, you have to use that, and it's really freaking slow. And so the only way that I could actually test this was to make a little change, wait an hour because it was so slow. Whereas the x86 one would take like 2 minutes, you know. And so, anyways, that was a long way to say that I would so much prefer to just send Wasm as my multi-platform thing. This makes so much sense for containerization, for the serverless, the cloud, the edge functions, than trying to finagle a non-multi-platform, non-sandbox technology into having both of those things.
Right. Yeah, it's like the old saying of like easy, fast, and portable. Pick two.
Right.
And so inevitably, easy is the one that goes out the window because all of this stuff is kind of cobbled together and unmaintained, and there's emulators and simulators involved. So I think Wasm could maybe break through free from that trade-off. I don't know.
Yeah.
We'll see.
There was an interview that Bill Venners did with, I think, Bill Joy many years ago about Java, and that you when you read this, you come away with, oh, they were in a big hurry. And so, because I mean, when you look at the number of mistakes, like pretty much all of threads had to be backed off. Oh, years and years later, after everybody was scratching their heads and were, why is my thread or program isn't work? And then the write once run everywhere thing, just, it was a good, it was a good try. It was a start. We all now believe in the idea, but it's not. I don't think it's going to be the way to do it. Whereas this, so here, that's a good question. What if I wanted to deploy something that was just the equivalent of a native app on, that I wasn't running inside the browser? Is there a equivalent of Node kind of?
There's a couple different implementations out there for Wasm that are detached from the browser, right?
Yeah. So if you're thinking about running on the server, there's Wasm only runtimes that will run your code on the server. There's also there's an interesting direction here which hasn't been that fully explored just yet, because before Wasm GC, it wasn't easy to write. Not a lot of people were writing user-facing apps in C++ anymore. But I think it's a really exciting area going forward. And that's the entire space of Electron apps. So apps that are packaging up web APIs, basically, and bringing them with them to the desktop platform. For exactly the reason you mentioned, right? Like the write once, run anywhere kind of ethos. VS Code is a great example of this. You can run VS Code in your browser and on GitHub Codespace, and then you can also run it on your desktop. And the way that they're doing that is by taking web APIs to the desktop rather than trying to do it the other way around. Yeah. So the prospect of something like Wasm, which brings kind of native performance to the mix, along with this sort of multi-platform, multi-language kind of capability, you could start seeing Wasm plus web APIs being packaged up as a native app through a technology like Electron, and then running at a rate that's indistinguishable on a desktop compared to native desktop applications on that platform. And so that's an area that we're digging into quite a lot, especially as it relates to bringing graphics APIs from the web to further the sort of write once, run anywhere ethos. If you design your UI to run against web canvas, then you actually can run it on multiple platforms. If you design your UI to use web GPU, you can actually do 3D graphics on multiple platforms. And so that's something that could be a direction that we take in the future.
So, and then on the packaging side, which I think you're also asking about, was today, if you want to run a Wasm program on your machine without not in the browser, you can get one of these Wasm only runtimes. Is that what they're called? Wasm only runtime?
I don't know if that's like the official term for it, but
Okay.
yeah, there's like Wasm Time, Wasmer, these sorts of runtimes.
Okay, and so Wasm time is one of these, and so you can install the binary for Wasm time, and then that's your Wasm interpreter. So you give it your Wasm file, and then you're running your Wasm on your machine. But I would guess that if it doesn't already exist, it will exist to be able to take one of those Wasm only runtimes and a Wasm file and create the native executables for different platforms to like do that packaging step. Maybe it already exists. I haven't seen it, but
Yeah, it's possible. I'm not sure if it produces like an exe on a Windows machine or something like that.
right. So I
It
think
probably is about
obviously
to
they
exist
will
if it
get
doesn't.
there at some point, but and be able to target like kind of the LLVM for Wasm. I'm sure will exist if it doesn't already.
So it almost sounds like we could eventually be to a point where we go, remember the JVM? And we go, no.
There's a big push from a lot of people that this is the way out of the JVM. And I think there's some real validity to that, because it's like, yeah, if your JVM was the thing that was giving you portability for Java bytecode, if we have a different bytecode and a different VM, essentially a different interpreter, then yeah, that definitely gives you an alternative.
I'll do you guys one better. So last year at Google I/O, we announced that our Google Workspace team is working on compiling Java code to WebAssembly for their web runtime. In particular, they have been working since last year to get the Google Worksheets calc engine, the one that kind of goes through your entire spreadsheet and computes all of the different formulas. That will be a module that is compiled to WebAssembly from the original Java code. Now, it's still it's kind of like a Google specific tool chain, but it is a big step in terms of deploying this at scale to users.
Speed and portability. So today, that team, they convert Java to JavaScript to run in the browser, to run that calculation engine in the browser. And you could imagine that that's not going to get you to the best performance that you would maybe like, especially for large spreadsheets.
Heavy calculation.
Yeah. We when we were playing with Wasm last week, we did a super quick Fibonacci test, and Kotlin has Kotlin.js and Kotlin Wasm, so it was pretty easy to say, okay, take this super simple Fibonacci thing and run it via JavaScript, Kotlin.js, JavaScript, and Kotlin Wasm, and like there was no code difference between these two, and the startup time or the execution time of this thing that we were playing with was like 7 seconds in JavaScript and 2.5 in Wasm. And I was like, okay, like I'm sure that like none of this has been like really like squeezed all the performance out of it yet. Like I know the Kotlin Wasm, it's super early. They have definitely not done a lot of performance optimizations yet. I think the Wasm runtimes, like they've not squeezed all the potential performance out of those yet. Like it just seems like, okay, we're at the beginning of this and we're already three times faster.
Yeah.
And
that's
there's a lot more headroom.
Yeah, for sure. We've seen at least 2x speed improvements on a number of different tests, including tests that call into web APIs frequently. Numerics benefit the most, probably, because of exactly what you said. You know, we don't have to worry about boxing a number and dealing with what it could be dynamically. And so, yeah, you're able to lower those instructions down into the machine code and use int64s and things like that native to the machine.
And like you said before, like the JavaScript stuff has been very tightly rung for like eking every last bit of performance we can possibly get out of it. Like I'm sure performance gains at this point in the JavaScript space are like, you really have to work hard to get like a 2% performance improvement, whereas with Wasm, I think we're just at the beginning of like what we're going to see on the performance side. So I think it's pretty exciting for performance for sure. I want to hop back to WASI. So we were talking about non kind of browser use cases for Wasm, and the cloud, serverless, all that kind of stuff. Definitely a lot of potential there, but often if you want to run something, you need to interface with the system, and that's where WASI comes in, is giving you the ability to call into certain system APIs, right? And we touched on this a little bit. Just wanted to go a little bit further because one of the things that I see like typical server side people getting excited about with Wasm is WASI. So did I characterize WASI and what it's doing correctly?
Yeah, yeah, no, that's exactly right. I mean, WASI is like it's doing for POSIX what WASM did for x86. So it's kind of like one little extra layer of abstraction and then making it available to the WebAssembly runtime code.
Yeah. And so this is still an area of pretty ongoing development. Like it sounds like WASI is not fully there yet, or what's kind of the general state of WASI?
It's ongoing in the sense that it's not fully baked, and the ecosystem continues to sort of add to it. But I would say that as a system interface, it does have POSIX to inspire that kind of conversation, and so there's a sort of rough sense of where it's going to end up. But there's discussion about particulars here and there about suitability for specific use cases or security implications, things like that.
That makes sense.
So I have two weird questions. One is, does Oracle have anybody on the WASM committee?
I don't know. I can check.
I mean,
So Graal they are adding WASM support through Graal. So you know how Graal native image is their way to take Java bytecode and ahead of time compile it into native binaries. And so that's the place where they have actually been doing some WASM work, which is, for, I guess, some speculation here that Oracle probably has to support WASM in some way, otherwise they miss out on the bandwagon. But I don't know what they would be thinking about in terms of how this threatens the JVM and what they have there.
Because it sure seems to.
Yeah.
So the other weird question is, I mean, JavaScript is so dominant, and so now you have this WebAssembly thing, and it makes me wonder if you could imagine somebody developing a processor that directly executed WASM assembly.
Do you remember when the people? I think his son was working on the like Java processors that execute Java bytecode.
I think they even had them.
So yeah, full circle. We're back to.
But this is well, okay, interesting.
It's close.
So do you know of anybody working on a WASM?
A WASM machine?
WASM chip?
Yeah, this probably touches. I have to confer with some of my more academic and technical colleagues, but I think there may be some. I think you would design an instruction set slightly differently if it were for a physical machine than for the logical machine that we had in mind. We always imagined that there would be this interim step of interpretation that would be very fast, but there would still be one between WASM and the physical machine. So I wonder if WASM has maybe baked in some assumptions there around that interpretation. I'm not sure how. But if they were trying to build a Java bytecode processor, then I could only imagine it'd be easier to build a WASM machine than that. But I'm not sure that it's on the radar right now.
The one place maybe related to this is that I hope to see WASM gain some traction is on the IoT space. So every time I've done IoT, it's geez, really this terrible variant of C? Really, I got to use that to work on this little processor? Man, if WASM
I've only used MicroPython, so
MicroPython is cool, but wouldn't it be nice if these IoT devices just ran WASM and then I could use whatever I wanted to write my WASM?
Well, and again, there's a place where a processor might show up.
See if the Arduino folks have more thought about a WASM Arduino.
So JavaScript is inherently single-threaded, right?
Yes.
Okay.
Except for workers, but that's yeah.
But so how does the Kotlin concurrency model map onto WebAssembly?
Yeah, so I mean, multi-threading in the JavaScript runtime environment has been a major open question with lots of different proposals and attempts at it, workers being one of them. And there's some trade-offs there as to how that is particularly implemented. Not all APIs are available in workers. Some APIs are only available in workers. There's a degree to which workers are heavyweight and take some time to start up and shut down.
They're sort of sub-processors, aren't they?
So we use processes differently for browser isolation. So it's not quite a sub process, but it is a heavy thread. It's a very managed thread, and in particular, the post message between workers and performance of communication between workers is challenging. The shared memory model is not quite there yet, although it's there's a version of it. And so for WebAssembly, yeah, you're absolutely right. There is an impedance mismatch between how static language developers like Kotlin developers think of multi-threading and coroutines. And I used to work on the Go programming language, and they call them Go routines, and they use them extensively. And so we have to figure out a model for that. There's some proposals and discussion around lightweight threading specifically for WebAssembly, and creating ways of carving out some processes within the WebAssembly static environment that are separate from how we do it in JavaScript. This, of course, opens up a whole bunch of questions around interop, which was your earlier question. And so now you've got multiple threads over here, and you've got potentially workers in JavaScript on the other side. And how do they talk to each other? How do they synchronize? How do they share memory? So yeah, this is an active area of investigation. But right now, workers is the path forward for multi-threaded, true multi-threading in JavaScript and WebAssembly.
Yeah, when you say all these things, there's a part of me that goes, "Oh, it's so much work. We'll never get through it." And then I also think, "Oh, but it's the web. The web, all the things that people have done. No, I think they'll get through it. They'll figure it out.
The web finds a way.
The web finds a way. It's just
exactly
too
right.
big."
And this is big enough of a topic, and there's enough eyes on it. I'm pretty confident we'll have a better answer pretty soon.
Yeah,
Mm-hmm.
that's exciting. Let's see other Wasm things. What else did we explore around Wasm?
Oh, well, surprising? What about the like Kotlin has their cross-platform user interface library that I'm not sure what state it's in.
So just today, unendorsed by Google in any way, but just today I saw tweets from the guy at JetBrains who's leading Kotlin Wasm. He shared Compose with Wasm, right, which is the Kotlin UI framework for Android, and that JetBrains has taken to other platforms, and they've made it work with Wasm, and the performance is astonishing. I didn't look super deep, but I think that at least part of the potential implementation uses Skia. So Skia is this graphics library that Android uses, and it's probably written in C++ or C or something. Anyways, they can Wasmify Skia, and then Kotlin Wasm can then just call right into Skia. And then there's a Skia to web canvas mapping. So that's how they actually get the pixels on the screen. So,
yeah, it's
interesting.
So I also work with our graphics team, and we're actually looking at some new primitives for very high performance graphics, and potentially making it easier to sort of build entire scene graphs in web APIs and then render them and update them very quickly at high frame rates. So yeah, it's a super exciting space anywhere you're doing something with any degree of intensity. So whether it's numerics or the sheets recalculation of all your formulas, or drawing low level graphics on the screen, Wasm is a great fit there. And I think the web APIs, now that Wasm is a thing, we can start to involve web APIs, considering that use case as well of draw commands coming from Wasm code at a very high rate. So that's super exciting in terms of what the graphics capabilities of the web will be in the next couple of years.
Yeah.
Is there any capability or in the system that would allow you to add WebAssembly instructions later? Like if you discover that, oh my gosh, we missed something, or the world has changed and now we understand something better. Can you do that?
Yeah, for sure. Yeah, I mean,
Okay.
an opcode is just a number, right? And so we just need everybody to
Well,
agree on
if
what that.
it's not in hardware, it's just a number. Yes.
Yes,
Yeah.
exactly right. And once we kind of agree on what that new opcode does and how it interfaces with everything else, there's definitely room to be adding more instructions. And I think that's definitely something we'll be doing over the
Right.
next
And
couple of
that's a
years.
reason that you wouldn't want to cast these things in hardware, that you would always want that ideally thin layer so that if you added another opcode, you could adjust that.
Yeah.
Mm.
It seems like performance is like the big reason for WASM in a lot of ways. Is there other kind of lesser talked about benefits of WASM that are also interesting?
Yeah, I mean, they touch on performance. Look, I mean, JavaScript is Turing complete, so anything that you can compute in one framework, you can compute in the other one. So it's definitely not a capability story, but performance itself is kind of one of these weird things where, if something is fast, it starts to become less a difference of degree and more a difference of kind, right? When you can really start to think about game engines and you can really start to think about advanced numerics and machine learning and that sort of thing running client side, then the equation of even business models change, right? Like, do we need to spin up a whole bunch of servers to do all of the work server side when everybody has these really powerful devices in their hands? We can ship a little binary that's the same across all of them. It runs on any architecture, and it runs relatively fast at very low cost. The main one we look at, the flip coin of performance is actually resource efficiency. So can we actually run heavy workloads without burning battery life on a device? Can we run workloads, for example, in a service worker that run periodically in the background and sort of like are downloading, caching, recomputing, transpiling, doing machine learning, doing federated learning, customizing content, that sort of thing, and shipping some of those workloads into the device for a whole host of reasons, like privacy, for example, not necessarily tracking users server side, but letting the user's device become gradually smarter at giving the user the content that they want from a particular service. So performance is one of those weird things where it changes the trade-offs and changes the assumptions of how people architect their services and their apps. And so it could realize benefits sort of, to privacy, for example, or to just, increasing the sort of compute power available to startups, for example, and allowing them to ship advanced models that run client side so that they don't have to pay for the servers. Those are the kinds of situations where performance gets really interesting beyond just running faster.
Yeah. Yeah, that the increased performance opens up new ways of doing things and new opportunities. And
Yeah.
remember we talked to Chris Hunt about Rust and why he loved Rust so much, and it wasn't necessarily about the language. Yeah, the language has some nice things, but he was like, it's about the resource efficiency that is produced from the language, and that is what was the most compelling thing for him about Rust.
Well, but he was also dealing with battery powered remote devices.
Right.
So
Yeah.
that was like an overarching issue for him. So yeah, it makes sense.
Yeah.
But as you're pointing out, it opens doors when you can be efficient.
Yeah.
I mean, ultimately, the whole point of computers is they can do things that we can't. and if I can do it at the same speed as the computer, it's kind of a toss-up.
Right. Yeah. Huh. Yeah, fascinating. I think one of the questions that comes up a lot around WASM is on the interop, and we've touched on it a little bit, but maybe just tell us a little more. Like, okay, so I've written something that's compiled down to WASM. Is there like an FFI already to like be able to make a call out to JavaScript and for JavaScript to call into me, or how does that?
Yeah, there are some,
work?
I would say, relatively rudimentary ways of calling back and forth and passing objects back and forth. But it doesn't. I would say it doesn't resemble what programmers are used to accessing directly. And so usually the way you would access it would be through a library. And so you would write a library that has some glue logic between the code that you're writing in JavaScript and the code that you're writing in Wasm, in Kotlin or whatever the other language is. Or the other thing you would do is, for example, if you're accessing web APIs that are in JavaScript, then you would have some kind of web API library in Kotlin or whatever language you're using.
We actually saw this when we did our sample. Was Kotlin has a library that you just say like document dot something that add element, and we gave it like our string or whatever, and it rendered it on the page. And so there was some mapping through a Kotlin API and Wasm to actually making a JavaScript call to like add a node to the DOM or something. Is that like
Yeah.
that
So
has to go through the FFI layer or whatever, right?
right, but that there would be some code in that library function that's maybe translating, re-encoding the string, or creating the JavaScript object. And so all of that kind of induces a lot of the sort of runtime overheads of JavaScript itself, because you're creating a dynamic object from a static object. It's something we've been poking around at, like trying to fix and trying to address. Where on the V8 side, we're looking at optimizations where we can detect that that's happening, and then sort of elide the JavaScript object creation sort of in the engine. But it's a very tricky space. It's something that requires a little bit more research.
Yeah. So if the DOM is some shared piece of memory, like could you essentially reference the DOM from Wasm and just like manipulate that directly or something?
Yeah,
I think that's been an area of exploration, but I don't know what the state
for
is.
sure. And the DOM, being a entirely JavaScript data structure, is entirely dynamic, and so you can attach new methods and do all kinds of crazy things to those objects. And so we have to support that or expose that somehow. But one thing actually that could be helpful is the string ref proposal I talked about, because a lot of the attributes on the DOM are strings inherently, and so we may not be able to speed up the creation of all these JavaScript objects without that sort of like interface layer in between WebAssembly and JavaScript. But at least some of the primitives that are very common in that data structure, we might be able to create sort of native versions of them. And that might get us sort of like 80% of the performance, we hope.
Yeah, that makes sense.
So do you have any sense of a timeline when we're going to start seeing? I know it's a terrible question to ask, but it's like, we're curious. When can we start doing stuff?
When can you make a web app that is Wasm and not JavaScript?
Yeah, like that. Just like, when might we hope to see some things?
Well, I think this year is going to be a very interesting year for WebAssembly and the web and application development on the web. There's a bunch of different things, some of which we've talked about, that are all coming together at once. JetBrains has been very active and has been sharing their results, and they've had incredible results compiling Kotlin, as well as Skia, as well as Compose to WebAssembly and running it in the browser. So that's super exciting. I anticipate some announcements from their end sometime this year. We mentioned last year at I/O that we're doing that internally for Java, and that's been a big part of kind of developing Wasm GC and bringing that to the ecosystem. And that's something that we plan to roll out in Chrome this year as well, so that more developers are able to, and more toolchain authors and language developers are able to experiment with it. And then, yeah, you mentioned sort of the cross-platform frameworks. So Compose, Jetpack Compose, which is sort of our version of it. We also have the Flutter framework, and a lot of different folks on the graphics side as well are looking at this sort of write once, run anywhere from a UI point of view. And so there's some work being done there on the Canvas and other web APIs to make that possible. So yeah, I think this year is going to be a year where we
are Wasm.
Yeah. Totally. It's finally the year of Linux on the desktop, right?
Yeah.
There you go.
Right. And when did that happen? When was the year of the Linux desktop? I feel like it happened.
No, it happened to me this year because
Did
I
it?
finally got my audio working on Linux.
Oh,
Yep, been using Linux on my desktop since. I go back and look it up every once in a while, like 92 or something like that. That's when I started using Linux on the desktop. And
but the audio
just this
hasn't
year,
worked.
nope, this year got it working. So this year is the year
was that because of Nix?
No, I got it working on Ubuntu,
Oh,
and then when I switched over to Nix, it just worked out of the box. I didn't even have to play with it.
That's mysterious.
Yeah. So, anyways, I think this is like the most exciting year yet for Wasm, and then there's just so much going into it from so many different angles that it's just going to get more exciting, which I think is why I see this hype around Wasm. And initially I was like, come on, like is this really that exciting? And I think it is. I think that it's going to be a pretty pivotal moment in the way that technology is built and used. And
well, just the idea that we could actually have a single app that runs everywhere is, it's like I stopped taking that seriously a long time ago, and the fact that it might actually happen, that's pretty cool. Because I don't want to think about all of those deployment. I mean, that's the thing. You think about how much time do companies spend, worrying about deploying to all these different platforms. And if you could erase that, it would, it was almost like when everybody who started an internet company had to run their own web server
right.
farms, and then we skipped away from that, and now, it jumps you forward. And this feels like it could be that kind of jump forward.
It does. I don't know if it'll happen this year, but probably next year, I think we're going to see like a major operating system that's just going to have Wasm support out of the box. Just like, you download a Wasm file and run it, and you don't have to install any runtimes, just as operating system supported. And then that's...
Yeah, that'd be nice.
That'd be nice. It'll happen. It's exciting.
Yeah.
Well, did we miss anything?
No, man, I think we covered a lot of ground. It's been great.
Yeah, thanks so much for joining us. I learned a ton, and super excited about Wasm. So thanks for all your work on it and making it better and pushing it forward.
Awesome. Great chatting with you guys. Thanks for having me.
Thanks for